Hello students, welcome to my class. Today I am going to take chapter number 14 from science, and the name of the chapter is force and work. Okay, so people often say that you will have to use force to do this, you will have to use force to do that. So we may think that to do something we have to do something difficult, we have to apply force, which is actually to do something difficult we have to apply force, which is actually not true. Okay, so even to do simple things we need to apply force, like writing or sharpening pencil. So to do small things, to do simple things, we also need to apply force. It is not in a way that only to do difficult work we have to utilize force, but for simple things also we have to utilize force. So what is force? Okay, so if you stay inside a room, okay, and you want to go out of the room, what we have to do? You have to push the door to open it, okay, to go outside the room. So in this case we can say that what a force is a push. Again, suppose you entered into a room and you want to close the door, so in that case what you will do? You will pull the door. So a force is a push or a pull on an object. Okay, so a force is a push or a pull on an object. Okay, so what does force can do? Okay, so a force, we can say, so now we are going to learn about the application of the force. So what does force can do? A force is used to move or stop things. Okay, a force is used to move or stop things. Okay, suppose there is a ball. Suppose there is a ball on the player's hand. Okay, suppose there is a ball resting on the player's hand. It will not move until unless we apply force on it. At the same time, so that from that we have to come to know that from this we have come to know that force can make a thing move. At the same time, we can see that whenever the players play football, okay, so they all want to hit the goal. When they kick the ball hard, the goalkeeper used to stop the ball. So in this case also force is utilized, force is used to stop the ball. So from this we have come to know that a force can make a thing move or stop. So the next one is force can change the position of an object. So as I said to you that if a ball, suppose a ball is resting in the player's hand, okay, so the ball will not move until and unless we apply force on it. So when we apply force on it, the ball will travel, the ball will cover certain distance according to the force which we have applied. So we can say that force can change the position of an object. Okay, so next one is what? Force can change the speed of an object. So how it's change the speed of an object? So if the force applied is in the direction of the motion of an object, then the force will increase the speed of an object. At the same time, if the force applied is opposite to the direction of motion of an object, then it will decrease the speed of an object. Okay, so from this we have come to know that force can increase or decrease the speed of an object. Okay, the next one is force can change the shape of an object. So if we squeeze a plastic bottle, it will shrink. So from this we have come to know that force can change the shape of an object. So at the same time, if we squeeze sponges, okay, so its shape will shrink, and then when we remove the force, again it will comes to its actual shape. So from this we can understand that force can change the shape of an object. Okay, so the next one is force can change the direction of movement of an object. A force can change the direction of movement of an object. So you have seen that whenever the players play table tennis or tennis, okay, so what they used to do? They used to hit the ball from one corner of the court to another corner. So in this case we have seen sometimes the ball go from, so what, every time the ball moves from one side to another. So from this we can say that, we can understand that force can change the direction of movement of an object. Okay, so now we are going to learn about the type of forces. Okay, so type of forces. So mainly there are two types of forces, that is contact force and non-contact force. So under this several others will come. Let's see. So we will learn each and every one in detail. Okay. So a force can be divided into contact force and non-contact force. Okay. So under contact force, so contact force is further divided into muscular force and frictional force, and non-contact force is divided into gravitational force, magnetic force, and electrostatic force. Okay. So force can be divided into contact force and non-contact force. So contact force can be further divided into muscular force and frictional force, and non-contact force can be divided into gravitational force, magnetic force, and electrostatic force. Okay, so what does contact force means? Okay, so the force act only contact. So in this case, the forces acts only when two bodies are in contact with each other. Okay, so in case contact force in the first case means, in this case the force act only when two bodies are in contact with each other. So under this we are going to learn about muscular force and frictional force. So what is muscular force? The force which act as a result of the muscle, the force which act as a result of the action of muscles are called as muscular force. So we use muscular force to lift things. We use muscular force to carry things from one place to another. We use muscular force to carry our school bag. Okay, so muscular force can be exerted directly, and muscular force can also be exerted by the help of machines. Okay, so if we are going to turn a piece of paper by our hand, okay, so in this case we have used muscular force directly, and if we are going to cut a piece of paper by using a scissor, so in this case we have used muscular forces by the help of machines. So muscular force can be used directly and muscular force can be used by the help of machines. Okay, so muscular force means what? The force means the force which act as a result of the action of muscle is called as muscular force. Okay, so now we are going to learn about frictional force. So simply we can say that frictional force is the opposing force. Frictional force is always acts against the direction of movement. Frictional force doesn't allow an object to move. Frictional force, due to frictional force, any object remained at its place until and unless external force is applied on it. So let us take an example. Okay, suppose there is a box placed on the floor. The box will not move from its own. Why? Because the force of friction, we know that frictional force always act against the direction of movement, against motion. So it will not allow, frictional force will not allow the box to move if we push the box. Okay, so if we push the box will move, the box will travel some distance, and again it will stop. So what makes it stop? It is frictional force which makes the box stop after having some movement. Okay, so from this we have come to know that friction always act against motion. Friction always opposes motion. Okay, so and friction always act between the two surfaces. So in case of box, the friction act on the lower surface of the box and on the upper surface of the floor. So due to the presence of frictional force, the box will not move from its position. Okay, due to the presence of frictional force, the box will not move from its place until and unless external force is applied on it. When we apply external force, it will move, it will travel some distance, then again it will come to stop. Why stop? It stops due to the presence of frictional force. So another thing we have to know that the frictional force will be larger, the frictional force will be greater if the surface area is rough, and the frictional force will be less if the surface area is smooth. So the frictional force will be greater, the frictional force is more in rough surfaces and the frictional force is less in smooth surfaces. Now we have to know, is friction good or bad? Is friction good or bad? So friction is also called as necessary evil. Okay, so along with this, it is also helpful to us. So friction can be bad for machines which have moving parts. So friction can be bad for machines which has moving parts, because due to friction the parts of the machine doesn't move smoothly. Okay, due to friction the parts of the machine doesn't move smoothly. That is why you have seen after Sundays people oil their machines. Okay, people oil their machines. Sometimes people oil the chains of the bicycle. Sometimes you have seen people oil other types of machines. Sometimes they smear powder on the board. So why they used to do it? They used to reduce friction. Okay, so if we know that if there is friction, then the things will not be able to move properly. To make the things move properly, to make the things run properly, they used to oil the machines. So oiling the machines reduces friction, makes the surface smoother, so that is why they can work properly. You have seen in case of when we go for playing carom, at that time what we used to do, we smear powder on the board. So when we smear powder on the board, the surface of the board becomes smooth, and it becomes smooth. So when it becomes smooth, the force of friction decreases in it. So that is why we can play nicely on the board. Okay, so friction also helps us in many ways. So friction between paper and pencils help us to write. Due to the presence of friction, a pencil doesn't fall from our hand. Okay, so we can write due to the presence of friction. Okay, so friction helps us to hold things. Okay, so this is all about frictional force. So now we are going to learn about non-contact force. non-contact force. Okay. So force. So what is non-contact force? So in this case, the force will act between the two bodies when they are actually not in contact with one another. Okay. So force act between the two bodies when they are not in contact with one another. So under non-contact force, we are going to learn about gravitational force, magnetic force, and electrostatic force. So first of all, we are going to learn about gravitational force. So every object in the universe, whether they are small or large, they used to pull other objects. So whenever we used to be inside a room, we used to pull the things which are present in the room. That means we exert a force on the things which are present in the room. At the same time, the things which are present in the room exert a force on us. Whenever we sit inside the classroom, we exert a force on our friends, and our friends also exert force on us. Okay. So but we do not understand it. Why? Because that force is very weak in nature. That is why we are unable to understand the force. Okay. So but the large object or the large heavenly bodies exert larger forces. Okay. Exert large gravitational force. So what does gravitational force means? We simply can say that the force which is exerted by the earth to pull a body toward itself is called as gravitational force. Even we people can walk nicely due to the presence of gravitational force. So gravitational force help us to stand upright. Okay. So now how hard the earth pulls a body depend on. So we know that if the weight of the thing is more, if the weight of an object is more, the earth will pull the object with greater force. Okay. So suppose you are to drop two objects from the top of the building. Okay. So the weight of one object is suppose 2 kg. Okay. And another is of 5 kg. So if you drop these two objects, if you drop these two objects from the same height, you will find the object which has more weight will come to the ground quickly as compared to the object which has less weight. So why this happens? This happens due to the difference in weight of the object. Okay. So the object which has more weight, earth's pull will also be more. Okay. So this is all about gravitational force. So now we are going to learn about magnetic force. Okay. Now we are going to learn about magnetic force. So we will learn the magnetic force. We will learn magnetic force with a activity. Okay. With an activity. So suppose you are given some iron nails, some pins, and some paper clips, some eraser. Suppose you are given iron nails, paper clips, erasers, pencils, or rubbers. Okay. And rubbers. So and one magnet is given to you. You are asked to see that the magnet attract which things. You will find the paper clips, the iron nails, and the pins will be easily attracted by the magnet, even if we do not bring the magnet, if we do not bring the magnet close to the things. Okay. They will be attracted easily. Okay. And if we bring the magnet close to the paper clips, so if we bring the magnet close to rubber, pencil, or sharpener, they will not get attracted by the magnet. So magnet doesn't attract all the things. Okay. So magnet attract the things which are made up of which are made up of iron, cobalt and nickels, and the forces by which magnet attract things are called as magnetic force. The forces by which magnet attract things are called as magnetic force. Okay, so now we are going to learn about the uses of magnet. So what are the uses of magnet? So magnets are used to lift iron from the garbages. So we know that the irons are easily attracted to magnets. So that is why to separate iron from the garbages, people use magnets. Okay, so magnets are used in refrigerator to keep the door closed. Okay, magnets are used in refrigerator to keep the door closed. So it is also used to separate magnetic and non-magnetic substances. So what does it mean? It means the things which are, so the magnets are used to separate the magnetic and the non-magnetic substances. Whenever we bring the magnet close to the mixture of magnetic and non-magnetic substances, so magnet will pull the things, magnet will attract the things which are attracted by it, and the remaining which are not attracted by the magnet will remain at its place. So we have come to know that magnets are used to separate magnetic and non-magnetic substances. Okay, so magnets are also used in speakers. Okay, magnets are also used in speakers which convert the electrical energy into sound energy. Okay, so now you are going to learn about electrostatic force. Okay, so what does electrostatic force means? So we can say that the force which is exerted by a charged body on another charged or uncharged body is called as electrostatic force. So when we rub something, it gets electrically charged. Okay, when we rub something, it gets electrically charged, and the energy stored in it, and the energy remains there, which is called as static electricity. So when we rub something, it gets electrically charged, and it has the ability to pull things such as paper. As for example, when we rub a comb or a pen or a pencil, it gets electrically charged, and the energy and the charge used to remain there, and the electricity and the charge used to remain there, which is called as static electricity. So this electricity or this charge object has the ability to attract small pieces of paper. Okay, so that is all about electrostatic force. We can say that again. I am repeating the definition. That is the force exerted by a charged body on another charged or uncharged body is called as static electricity. Okay, so what is the amount of force which is needed to do something? Okay, which is needed to move something, which is needed to do something. First of all, the force required to do something depend on how heavy the thing is. If the thing is heavy in weight, we have to utilize more energy to move it. We have to use more force to move it. And the next one is how fast we want to move it. So if we want to move it faster, we need to apply more energy. If we want to move it slowly, we need to use less force. Okay, so the force needed to move something depend on how heavy the thing is and how fast we want to move it. Okay, so if the thing is heavy in weight, we need more force. If the thing is light in weight, we need less force. If we want to move it faster, if we want to move it faster, we need more force. If we want to move it slowly, we need less force. So now we are going to learn about work. So what is work? When we apply force on an object, and if the object moves, then we can say work is done. So after applying force, if anything moves, then we can say work is done. And after applying force, if a thing or if an object does not move, does not changes its position, then we can say work is not done. Okay, so the work we do, the amount of work we do, depend on two things. First of all, the amount of force we use. If force applied by work is more, if force applied by us is more, work done will be more. If force applied by us is less, work done will be less. Secondly, the distance through which the things move. Okay, so after applying force, if the thing cover greater distance, if the thing travel greater distance, then work done is more. After applying force, if the thing travel or cover less distance, then work done is less. Okay, so as for example, when we apply force on a table, so after applying force on a table, if it moves, if it changes its original position, then we can say work is done. So after applying, and secondly, when we apply a force on the wall, so definitely it will not move how much force we use, no matter how much force we use. So if after applying force, if anything doesn't move, after applying force on the wall will not move. So we cannot say, in this case we cannot say work is done, in this case work is not done. Why? Because the distance traveled, the distance covered after applying the force is 0. That is why work done is 0. That means to do work, we have to apply force. Along with this, the object must changes its position. If it doesn't changes its position after applying force, no work is done. And if it changes its position after applying force, work is said to be done. So if you carry one book from one table to another, at the same time if we carry two books from one table to another, so which case more work is done? In the first case, you have carried one book from one table to another, so in this case less work is done because the weight of an object is less. So at the second case, what you have done, you have you have carried two books from one table to another. In this case, you need more energy, you need more force to lift the book from one table to another. In this case, you need more force, that is why more work is done. Okay, so work done equals to amount of force into distance moved. Work done equals to amount of force into distance moved. Okay, so if after applying force, if distance moved is 0, then work done equal to 0. Okay, so if distance moved is 0, work done equals to 0, because whenever anything multiplied by 0, it becomes 0. So anything, we know that anything multiplied by 0 is 0. That is why we can say work done equals to 0. That means from this from work, we have come to know that, from the topic work, we have come to know that when we apply force on an object and the object moves and the object changes its position, work is said to be done. That means after applying force, if anything moves, if anything changes its position, work is said to be done. And after applying force, if anything doesn't move, if anything doesn't changes its position, work is not done. Okay, so work equals to amount of force into distance moved. So if distance moved is 0, work done equals to 0, because anything multiplied by 0 is 0. So this is the end of your chapter. If you have any kind of problem, so you may talk to me at night from 8 p.m. to 10 p.m.